Oh, I'm in Malibu.
Okay.
Yeah, I'm in Malibu. Hey, so today I am so honored to have our guest, Moises. Is that how you guys pronounce her name, Moises?
Yeah, Moises, the accents on the final syllable.
Moises. Okay, great. I
Yeah.
always get the names wrong. Okay, perfect. Today I'm so honored to have our guest, Moises Velasquez-Manoff, on the show today. He is a fellow blogger at moisesvm.com. Moises has written extensively, mostly on science and environment, for the Christian Science Monitor. His work has also appeared in the New York Times Magazine, Chicago Tribune, and the Indianapolis Star, among other publications. Moises Velasquez-Manoff's first book, An Epidemic of Absence, is a brilliant, cutting-edge exploration of the dramatic rise of allergic and autoimmune diseases and the controversial, groundbreaking therapies that scientists are developing to correct these disorders. And his book explores, why we're so vulnerable to immune system malfunction, evident in the dramatic rise in the cases of allergies and autoimmune disease. So, Moises, thank you so much for being on the show.
Thanks for having me.
So, why don't you tell the listeners a little bit about yourself and why you wrote An Epidemic of Absence?
Well, basically because I have been afflicted by some of these diseases my whole life. So I've had food allergies my whole life. I'm allergic to peanuts. I grew out of my allergy to eggs, but I'm still allergic to peanuts and sesame. And then I have asthma, and I have an autoimmune disorder called alopecia areata, where my immune system has essentially attacked my hair follicles, leaving me hairless. So it's been a constant presence in my life. And I think when you're a kid, you ask why, and the doctors can't answer you because they don't know why this happens to you. They don't know where it came from. What they can try to do is treat it, and in this case, the treatments aren't very effective. No one knows really how to deal with autoimmune disease generally, and in terms of allergic disease, everything is about managing the symptoms, not about fixing it entirely. So, as a science writer, as I was starting, a few years ago, actually some time ago at this point, but I was starting, and I thought I'd look into this question again of why these diseases, first of all, happened to me. And the first thing I discovered was that they weren't just happening to me; they were happening to everyone. One of the alarming trends in the late 20th century was that these diseases were increasing pretty dramatically in prevalence, like 2 and 3 times for allergic disease, and even more for some of the autoimmune diseases. Up to 4 times, 3 times. Far more for things like inflammatory bowel disease. And so everyone's using the word epidemic to describe this increase at the end of the 20th century. I decided to write around one of the really interesting theories trying to explain the increase in these diseases, which the theory has been called the hygiene hypothesis. That's almost everyone who works in this area thinks that's a horrible term, even though that's the one that's stuck. And very, very briefly, the idea is we're just too clean for our own good. But then, of course, this is not about personal hygiene. It's not about taking showers. This is about what we've done as a society and lost contact with an array of organisms that actually properly calibrate our immune system. And then, not taking a shower is not going to really help you in that regard.
Yeah.
So that's the genesis of the book.
Well, so you refer to bacteria, probiotics, and parasites as old friends in your book, An Epidemic of Absence. What exactly do you mean by this?
So that's a term I borrowed from a scientist named Graham Rook. And he's trying to think up better ways of formulating the hygiene hypothesis because everyone thinks about showers when we talk about it. And what he's getting at is that these are organisms that have been with us possibly since the Paleolithic, but they're organisms that were sort of ever present during human evolution. And there's an important distinction there. This is not about infections like pandemic infections, like the plague, or like smallpox, or like some of the measles even, or the flu. Because those organisms, some of which are bacterial, some are viral, are organisms that are very recent arrivals to the human body. Most of them jumped over from animals. So, we settled down the farm about 12,000 years ago, 10,000 years ago, got all these animals, domesticated them, and then we started acquiring their viruses and some of their bacteria, and those became human pandemic diseases. And one way to look at it is that organisms that cause these diseases, they are sort of they haven't figured out how to be in your body without killing you, essentially. So if you look at it from the perspective of an organism that's trying to survive, which they're trying to do just like you are, that's a bad strategy in small groups of people, because then you kill all your potential hosts and then you have nowhere to go. So the organisms that are old friends have a much older kind of strategy that goes back to times when we were small groups of people. And what they do is they persist in your body and they don't kill you, because it's counterproductive. Those include intestinal parasites, which they don't reproduce. Most of the species, in any case, don't reproduce inside your body. They actually, so you can tolerate a certain number of parasites and sort of not have to evict them, because you don't have to worry about them replicating like mad, like say the smallpox virus, and basically overwhelming you and killing you and turning you into kind of like mush. They just sort of sit there and you can tolerate them. And in fact, tolerance is a kind of survival strategy for the old friends. And of course, I'm talking about the bad old friend. That is, the old friends that have a cost on your body. There are also, if you think of a sort of gradient of organisms, on one side are the parasites that have a cost, but they may also properly calibrate your immune system. On the other side are the purely good mutualists. And those are sort of the intestinal bacteria that are more like symbionts. They're more like the bacteria in, let's say, cows that help them digest grass, or the bacteria in any organism that needs its bacteria, which are most organisms, to digest its food. We just don't think of we haven't historically thought of ourselves as falling in that category, but we do, it seems, fall in that category, which is that we have these very highly evolved, long-standing relationships with bacteria, and they help us digest food. They help calibrate our immune system, and maybe most important, they protect us against organisms that otherwise might come along and just turn us to mush. Well, those are the old friends.
Don't the old friends just become a problem, say, when the host itself, the person, is nutrient deficient or ill or toxic, and then these parasites are able to grow out of control, and then they start causing problems? It's kind of like the level of infection.
Well, I'm not willing to say that. I think that parasites are parasites because they're stealing something from you. It's a strategy. It's a survival strategy where instead of getting into a relationship where they are purely contributing to some greater whole, what they're doing is they're mooching. So what they take from you is a whole bunch of stuff depending on the parasite. But let's say hookworms. Hookworms are actually eating you.
Yeah.
So at the same time, they're manipulating your immune system. And the way this theory works, at least with regards to parasites, is okay. So animals, or that is parasites like hookworm, have been always present on the human body, and they're always present in most animals. If you look around the animal kingdom, they do something. They have a very powerful, persuasive influence on your immune system. That kind of influence was always there. So in some respects, our immune system maybe evolved as optimized to operate under those conditions. So if you think of it like if you had a ball and chain on your foot, and you just always had this ball and chain on your foot, you'd have various compensatory mechanisms to deal with that. And then you suddenly remove the ball and chain. In some ways, you're free, but in other respects, you're gonna be very awkward now, because you're not gonna have this weight that you expect pulling you back, and you might overcompensate in other ways. And the analogy is that our immune system is now hyperreactive. It's more responsive than it really should be because of the loss of parasites. But am I willing to go so far as to say that parasites are purely good if you are, if a bunch of conditions are met? Possibly, if you're well fed, they won't have any obvious cost. But if you have too many, they cause disease. I mean, I don't, and if you have different types, they can cause, the schistosomes that live in the veins around your colon and bladder. They pierce your skin in the tropics when you're wading in clear water. I mean, they can they can cause bloody urine and all sorts of things. I mean, that's not, if you have blood in your urine, that's just not good. It means that there's some damage being caused.
Yeah.
Right? So I know that there's a tendency to want to say that, because it's like to deal with with the cognitive dissonance of the idea of having something that's hurting you also helping you. But I think it's important to sort of resist against that tendency, and just keep a nice, strong, clear view of the fact that these things are, when something is a parasite, it's for a reason. That's because they have an arrangement where they're stealing something from you.
Okay.
Just because you always have a thief present doesn't mean that thief is always good.
Yeah, yeah. Well, you know what? Another thing I wanted to talk about is antibiotics. What are antibiotics doing to our health and the health of our families? Because there's a growing body of evidence that suggests that the very steps that we're taking to combat infections also eliminate organisms that keep our bodies in balance and modulate our immune systems.
Yeah, so the clearest way to think of that is there are the organisms that want to kill you, and then there are your symbiotic organisms. Antibiotics take them both out. They don't distinguish. So you're going after some horrible infection, you take a course of antibiotics, and you end up knocking out also all these symbiotic organisms that do all the good things that you just mentioned, like calibrate your immune system, your metabolic function, synthesize things for you. And maybe worst of all, you have an array, at all times you have an array of bacteria in your gut. And some of them are kind of like, they're called pathobionts. And what that means is that they don't cause any harm when they're in small amounts. They just sort of sit there. But then you knock out everything else that's holding them back, and they expand, they bloom, they come out. It's sort of like one of those toxic algae blooms in the ocean. The algae is always there. It's just only when they have the opportunity, they sort of overwhelm everything. And so what antibiotics, there's several ways that antibiotics can be dangerous, at least according to this emerging picture. One is that they kill bacteria that are very good for you, and some of those bacteria, in fact, the animal studies demonstrate that those bacteria that are actually most important for the kind of immune stimulation that we want, that we need, which is to calm your immune system down, are more vulnerable to the broad spectrum antibiotics. So you end up knocking out particularly healthy bacteria accidentally. And the second way is that you end up opening the ecosystem to these bacteria that are already there, aren't causing any problem in small amounts, but then expand and start causing big problems. And, the classic example is Clostridium difficile, which is this horrible infection. It's antibiotic resistant. A lot of people actually have Clostridium difficile and they have no problem. It's because it's just sort of held in check. It's just sitting there waiting for its chance to expand. And then you knock out all the bacteria. It gains a foothold somewhere new. The numbers explode, and then you have this horrible infection that can lead to death very often. That it's basically causes a kind of inflammatory bowel disease where you can dehydrate to death or bleed to death or all sorts of things. And of course, as you know, what's the cure for C. diff infections? Stool transplants. It's like the most effective cure that anyone could have dreamed of, and that means taking a little poo from someone who's healthy and putting it in the gut of someone who has this infection. And what's so interesting, and what the lesson is from that example, is that you don't kill off the bad bug. You just restore the ecosystem, and the bad bug goes back into whatever corner it came from.
Yeah. I've been reading a lot about that lately. It's really, really interesting, and it makes a lot of sense.
Yeah, I mean, it's ecosystem theory. It's an ecologist gets this stuff right away.
So when we knock out the good bacteria with antibiotics, can they simply be replaced with probiotics? A lot of people scramble to take their probiotics after their course of antibiotics. Is that enough?
Well, there's some indication that probiotics, what they do is, first, let me just back up. The current generation of probiotics are often, they're untested for many of the applications for which people buy them. Doesn't mean they don't work. It just means that it's not shown that they have worked. Number one. Number two, they're sort of arbitrarily chosen in the sense that they say, okay, this is found in fermented milk. Let's manufacture it and we'll feed it to people. It's got to be good for people. That may or may not be true. No one really knows. So they're really kind of untested. The bacteria we want are bacteria that are native to the human gut. Again, they're not the same ones that are going to be in fermented milk. Those are bacteria that are native to fermented milk. It doesn't mean they're not good for you. Again, we just don't know. But so one way, though, that even those bacteria can help is they colonize you transiently. And there are a few studies at this point, or at least one, that show that when you take antibiotics, if you take probiotics, it lowers the risk of one of those opportunists moving in, just by sort of occupying the niche. transiently, right? It doesn't, you don't, when you take probiotics, often what they find is that it doesn't permanently move into your gut. Like what you'd like is you take it once and then you'd have this new bug in there that's good for you. But that doesn't work that way. You have to keep taking it. When you stop taking it, often it just goes away. It's just sort of a transient colonization. But that may be enough to prevent some of these diseases we're talking about. Not the diseases, that is the infections that we're talking about. And I think it's, since there's very low potential cost and a lot of potential benefit, I don't understand why doctors aren't doing this routinely. You just, prescribe a probiotic when you give an antibiotic to prevent this horrible outcome that sometimes occurs.
Yeah, it drives me insane. It just doesn't make any sense to me why physicians aren't doing that. It makes no sense. But what about also, is it, reasonable for people to start eating probiotic foods or foods that promote the growth of probiotics, like inulin and things like garlic and onions and Jerusalem artichokes and things like that promote growth of good bacteria?
Yeah, I think that is going to end up being have a better effect actually than some of the probiotics that are currently available for purchase, because what you're doing in that case is you're just feeding the bacteria that you already have that are good for you, selectively feeding them. There's a lot of ongoing research in that area. But what you notice there though is, instead of taking a pill, a capsule of inulin, it's just eat real food. It should be part of your food already if you're eating well. Because again, a capsule of inulin, think about how big it is, and then think about how big an apple or potato or an actual Jerusalem artichoke, which I've never had actually, but and I understand they're not actually artichokes.
Yeah.
But just the actual, think about the bulk of what real food is compared to a little capsule of inulin. I just think that we'll just design your diet to be full of real food, real plant foods that are full of these digestion-resistant starches and full of polysaccharides and full of basically, what's already sort of coming out in literature. The Mediterranean diet is full of that kind of stuff. Because I don't know much about the Paleolithic diets, but as I understand, there's a lot of sort of vegetable eating there too.
Oh yes, very much so.
Nuts and
lots of veggies. It's not all meat.
Yeah, right. So just eat well. I don't think it's necessary to go start taking pills to get this effect. Just eat right.
Yeah, it definitely seems to make more sense to me to eat foods that just promote the growth of the bacteria that's already there and you're good.
Yeah.
So, a huge topic in the health sphere today, and the topic of your book, is how an unhealthy gut microbiota contributes to all manner of disease and health conditions, including autism and autoimmunity, allergies, depression, obesity, you name it. So how does an unhealthy gut contribute to such a wide range of health issues?
Well, it's sort of like, let me count the ways, but I'll just, since my focus was on the immune system, I will just point out that right now there seems to be an explosion of literature that implicates the immune system in just about every disease that we are afflicted with, that is non-communicable diseases, which are the main sort of disease burden in the developed world. That the immune system is doing is causing a lot of the problems. And there are two ways that happens. One is if you're sort of chronically inflamed, that causes damage. You know that because, say, if you have an infected cut, that's a kind of inflammation that's going on around the infection that can cause a lot of, pain. Think of just a pimple or something like that. A lot of that pain is actually from your immune response, not from the bacteria that are causing the infection. But the second thing is a little bit more subtle, and that is that when you have sort of chronic immune activation, all the normal stuff that keeps you healthy and alive doesn't stop, but it goes to a bare minimum. So in the short term, that's fine. You have some acute problem. You have a fever, say. You get rid of the bug, and then you go back to normal. You return to homeostasis. But with the problem with having changed our gut bacteria, say, is that our immune system is chronically active, possibly, so that there's this chronic interference in neurotransmitters and metabolic function, which has to do with things like insulin, and there's this chronic sort of just it's almost like you have a smoldering fire in your kitchen or something that's just going on, not allowing you to live your life normally, but in your body. That's biologically happening. And that contributes to every single disease of civilization. Or maybe I shouldn't exaggerate, but many diseases of civilization, from dementia to especially obesity, which is again linked to all the other ones, but in heart disease and arthritis. I mean, everything we have essentially.
Well, let's talk about autoimmunity. It's one of the fastest growing subsets of diseases in the world, affecting between 5 to 8% of the U.S. population alone. So why is autoimmunity becoming such a plague?
Well, I'll use an analogy to illustrate one reason why. There are some genes that are involved in making your white blood cells. So you have white blood cells. They're there to protect you. They fight off bacteria, and they make sure that those pathogens don't turn you into dinner, basically. But there are some white blood cells that basically turn the other white blood cells off. You can think of them as the in the canine patrol, they're the handlers of the dogs, so the guys who hold the dogs' backs. So if you take away the handlers, you just have a bunch of really nasty, snarly, mean dogs. And actually, genetically, there are genes that correspond to that function. So that there are genes when you turn them on that turn cells into handlers, allows those cells to hold back the other cells. There are certain genetic mutations that occur spontaneously, where those genes are taken offline. And what happens? Those kids, they usually don't live very long. They sort of have this meltdown of autoimmunity, where all their attack cells turn against their own tissues. They also have these horrible responses to viral infections, where it's just they essentially self-destruct, and they have sort of eczema, allergic disease, where basically their immune system has no ability to restrain itself. It goes crazy. So in modernity, we know that in the late 20th century, we know that these diseases have increased. We have done probably what that mutation did environmentally without any mutation. What we've done is you could think of it as we are not expressing that set of genes as much as we need to and as much as we used to. And that the reasons are environmental for everything we're talking about, because expression of that subset of genes, of those handlers on the canine patrol, was dependent on contact with all the old friends. And we basically lost contact with all the old friends, or many of the old friends. That's the explosion of autoimmunity. So many people think of it as something must be provoking it. We're exposed to new infections, or we're exposed to toxins. I mean, toxins may be able to provoke it, but one really easy way to provoke it is just to simply remove the handlers off the dogs, and the dogs go crazy.
So, I've heard that to have an autoimmune disease that you have to have a leaky gut first. Is that true?
It's unclear, only because no one has ever, or at least so far, no one has prospectively followed that. First of all, no one knows who's going to get autoimmune disease. You can sort of predict because there's some in the family sometimes. But to answer that question, what you do is you'd follow someone who has an autoimmune disease in the family and take measurements of their gut and then see what happened first. It's certainly possible. I think it's much more likely that there are many roots to what we call an autoimmune disease. So one root may be that there are gut problems that trigger it, so that things get through the gut. But I also think that if you have an autoimmune disease, you may subsequently develop a leaky gut. So I think there are many ways to end up in the same endpoint. There are many paths to the autoimmune disease endpoint. Okay.
Well, my daughter was diagnosed with a mild form of autism, so this is a topic of special interest to me. So can you elaborate a little bit on why you think autism is reaching such epidemic proportions and what this has to do with gut flora?
Well, the hypothesis that I find most compelling, because it's supported by so much epidemiology, is the idea that something happens during pregnancy that triggers the maternal immune response. Or it's not really a trigger, it's more that the maternal immune system is a little bit more activated than it should be, and that some of those, so what happens is that immune signaling proteins, they can cross the placenta, and the brain brain is developing, and it turns out that for reasons no one quite understands, neurons, as they are migrating into place in the developing brain, actually use immune system signals to get into place, to figure out where they need to go. So what happens is you're changing the signaling of where they need to go a little bit, so you end up with a brain that's a slightly differently wired. And so the evidence in support of this idea is that, the factors that are predictors of autism include infections, if mothers happen to get an infection while pregnant. They also include if the mothers happen to have an autoimmune disease while pregnant. And they include if the mother has an allergic disease or a metabolic disorder. And one of the symptoms of a metabolic disorder is this low-grade inflammation. So there are all these things that point to inflammation being a factor in pregnancy, plus it's supported by, at this point, a number of animal studies, including on primates. But if you back up for a second, and then you think, okay, well, so our immune system may be operating differently than it did in our past because of these changes to the environmental inputs, changes to contact with old friends. You're going to immediately say, okay, well, the immune system has its fingers in a lot of different aspects of being alive because it's really important. And one of those aspects is pregnancy, of course. I mean, there's this very intricate balance of tolerance and non-tolerance that has to happen during pregnancy, essentially because the mother is tolerating something that's foreign inside of her. That's what a baby is. A baby is, there are these weird parallels between babies and parasites as an aside, but a lot of if you look at the pregnancy literature, you see that actually there's this sort of analogy where they call the baby a parasite because it's actually sucking stuff out of the, like the calcium from her bones, and it's actually just taking all these nutrients.
That's how it feels too. Like you're so depleted after you have the child. They robbed everything.
It's just a parasite that lasts 25 years, right? Or periods of economic uncertainty even longer.
Yes.
So you would expect if you change the immune function, you would see sort of accidents during pregnancy more often. It may be that autism is one of those. So the hypothesis as to gut flora would be that it's actually the mother's gut flora changing her immune function or altering it, and then changing development of the fetus via its modulation of the maternal immune system. That said, a number of studies have also shown differences in gut flora of autistic children themselves. Again, it's the cause and effect problem, number one. Number two, those studies are all over the place. Some studies don't show any difference. Number three, the differences they do show are never quite the same. So it's totally undecided at this point, whereas I think the prenatal stuff is much more compelling and consistent with itself.
It's really compelling, and it definitely makes sense. It makes a lot of sense. So let's talk about food sensitivities a little bit, because this is a huge factor that affects 70% of the population. And I've heard some new theories on food sensitivities that they're not only caused by leaky gut, but can simply be the result of not having gut bacteria to digest our food properly. Take grains, for instance. Chris Krusser spoke about the idea that we don't handle grains well due to an impaired microbiota in his speech at the 2013 Ancestral Health Symposium. And it may not be that grains themselves are the problem, but our gut dysbiosis. So what are your thoughts on this issue?
Well, I mean, I've written about that, for the New York Times, especially with regards to grains. I agree. So I think I never really bought the idea that the grains themselves were changing, because I don't really think that I don't think that you should be responding to proteins that aren't also damaging you somehow. In other words, your body should be able to distinguish between things that are attacking you and things that aren't. And a grain, the peptides in wheat that seem to bind to those receptors are simply not attacking you. So the argument has always been, okay, well, in people with those genetic variants, the grain binds more tightly to the receptors, and thus they're more vulnerable to having celiac disease. That may be true, but there's a deeper understanding of immunology where you can bind your white blood cells can bind to proteins and not not present them to the rest of your body as a threat. It can do the opposite. So the question is not whether or not they bind. The question is why they're suddenly presenting them as a threat. And it turns out there's all this terrific research on what microbes are present can determine whether your white blood cells perceive these patterns, these are just proteins, the glutens, as a threat or not, or whether they perceive them as what they are, which is just another protein coming down the alimentary canal. So this is hugely important, and I think that it's also the answer to why we have food allergies, the answer to why we're increasingly allergic to just about everything, really. It's what else is there that's determining how you respond to the incoming proteins.
Yeah, I think that's really, really interesting. It has a huge impact on just people improve their gut flora. They can start eating more foods that we previously thought are bad for us. Because I don't buy a lot of the arguments in the paleo world. I don't take things at face value. I want to know why. I'm sure the listeners do as well. So let's talk a little bit about H. pylori, because this is another big issue, because this parasite infects roughly 50% of the population. And, many consider a bad parasite something that must be eradicated with antibiotics. I went to my doctor and they said, oh, you have an H. pylori infection. Let's give you antibiotics. And I was like, whoa. I just did some Manuka honey and the infection, so-called infection, went down, was reduced. So is it possible that this organism is not as problematic as many think?
Well, were you having symptoms?
No, I was not. But my father, I was having some health issues. Had been vegetarian for a couple of years, and I didn't feel good, and I just didn't have any energy. All kinds of little weird issues, thyroid issues. So I just check everything. So that's where that diagnosis came from, just in my blood work. But I was reasonably concerned because my father died of esophageal cancer, which could, many people think that, or their studies show that H. pylori can lead to stomach cancers and things like that. So, just my question is this organism, like, we know that it can lead to certain cancers and other ulcers and things like that, but is it as problematic as we think?
Well, yeah, it is definitely linked to stomach cancer, which you don't want to get. It's definitely linked to ulcers, which you also don't want to get. But it's, like everything, a little bit more complicated. And one of the emerging ideas is that, so let's back up a second. The reason that helminths, that worms, the way they manipulate the immune system is they basically induce all these cells that are suppressive. I talked about the handlers on the attack dogs. They basically conjure up handlers for attack dogs, right? And then there's something called the bystander effect of that, which is that all your immune activity going on is suppressed. These handlers run around and grab all the dogs. H. pylori does the same thing. The way that it is able to live in your body for so long and not be fought off is that it convinces your immune system to tolerate it on some level. Now, if you get cancer or ulcers from it, that is actually a failure of tolerance and a failure of it to induce those cells in you. So one reason that may happen is you don't get it early enough. So it seems that there's something called the African paradox, which seems to suggest like Africans can harbor H. pylori without as many troubles as Europeans. Now, part of that is the strain that is in Africa, but it's also that if you get it earlier, some of the animal studies show, you tolerate it better, number one. Number two, it induces more of those cells. Number three, it's more protective against asthma later because it induces those cells. Let me just emphasize, though, if your doctor says get rid of your H. pylori infection because it's causing gastritis or what have you, you should probably do it because it's probably a problem. Now, if they just happen to find it and they say you should get rid of it prophylactically, well, that's a different question. That's a very difficult. It's funny that you mentioned that, actually, as an aside, because I was at a gastroenterologist a while ago, and he was saying that he refuses to get tested for H. pylori because he knows all this science. He knows also that, not all of it, he knows some of it. He knows actually that it seems to protect against gastroesophageal reflux disease, heartburn.
Yeah.
Which he did, so like you can get rid of it and immediately start getting heartburn. Heartburn is actually not that easy to treat if you have it chronically. So anyways, this stuff is like making inroads, and there are even doctors who refuse to get tested because they don't want it, because if you have a carcinogen, which H. pylori is classified as, you're supposed to get rid of it, period. That's just what the manual says. Anyways, like all things, it's way more complicated. It may protect against allergic diseases and possibly some other inflammatory diseases, but it's also even more so than multicellular parasites, than worms. It has a dark side because because how you respond to it greatly determines whether it hurts or helps you, and how you respond to it is determined by when you get it, by your genes, by what other bacteria are also present. There are some really interesting studies showing that, like, if you have a lot of lactobacilli, you tolerate H. pylori better. So there's all these second-party factors that can determine whether or not you come down with gastric cancer, which is a big deal. That said, Martin Blaser, who sort of pioneered the whole H. pylori, let's just call it like a rebranding, he does argue, I don't know if he's being provocative, but he does argue that kids should have H. pylori and then have it eradicated as adults when it becomes a risk factor for cancer. That way you get the benefit, but not much of the cost.
Yeah, that's interesting.
Yeah.
Well, let's talk a little bit about worm therapy. In the book, you tell the story of how you went to Tijuana in Mexico and to infect yourself with a hookworm. So I keep hearing all about studies or individuals healing themselves with hookworms or fecal transplants that you talked about earlier. Can you elaborate on some of these terribly interesting new treatments?
Yeah, well...
and why you played guinea pig?
Yeah, so I'll answer in reverse. Okay, so there's all this science suggesting that parasites are protective. The animal models are, meaning mostly rodents, are completely unequivocal. Parasites protect against everything in animals. Then there are these human studies where a scientist named Joel Weinstock developed a parasite native to pigs for the treatment of inflammatory bowel disease, had these incredible results in his first very small trials on humans with Crohn's and ulcerative colitis. So as I recall, it was like 75% cure rate, remission. I mean, this is a disease that's very difficult to treat. It's very painful. It's a horrible disease. And he had this amazing rate. So what's happened, there's other work as well, studying parasites in naturally infected people, showing that they, of course, have fewer of these diseases. So you put that all together, some human studies, animal studies are unequivocal, and then correlative observational studies where populations that have hookworm, for example, have less asthma. And what you get are a bunch of desperate people who decide to take things into their own hands and start treating themselves with parasites. And the parasite of choice in this case is, in my case, the one that I explored was hookworm. So people are selling it. So I arrive on the scene a few years ago, and I become aware of this underground movement, which I call the hookworm underground. I find some people that have some remarkable stories of remission that I'm able to sort of confirm. I also find some people who don't do so well, who I'm also able to confirm, who basically it makes things worse for them. And I decided just to go test it myself. Like there's no way, you don't know what to believe until you test it yourself. Right?
You are a brave soul.
So I go down to a clinic in Tijuana, of course, where everything that's not approved by the FDA goes. And I get 30 hookworms. They go through your skin. You feel kind of itching. And so to make a long story short, I have some pretty not pleasant symptoms. But it's also true that I see some improvement in my eczema disappears.
Good.
The best part was actually that season of hay fever. For half the season, I had no hay fever. Like, it was this incredible just clarity in my nose. And that's been reported actually in literature before. By scientists who experimentally infected themselves. That was the other thing, though, is I knew a bunch of scientists had experimentally infected themselves, so I knew it couldn't be that bad if scientists were willing to do it. People who basically are trained in how horrible these things are were willing to do it. It couldn't be that dangerous or that bad.
If it didn't work out, you can just eradicate them, right?
In theory, yes. But the truth of the matter is, actually, I did eradicate them after about, I think it was 2 years. Now I'm forgetting how long I had them. But first of all, the beneficial effects were very variable when I had them, number one. And number two, the side effects never really went away. Now, I had interviewed people who had like no side effects. I couldn't figure that out. I don't know if they were just so, I don't know if their primary condition was so terrible that anything was an improvement, so like it was a relative thing that since my autoimmune disease is essentially cosmetic, I'd feel maybe very differently if I was going from inflammatory bowel disease to the symptoms of a hookworm infection, which are probably less. But I don't know. I interviewed people that I said they had no symptoms. I suspect part of that is genetic. Everyone responds differently. And I suspect maybe some of them had taken immune suppressants prior to trying the worms. So maybe, what hurts you in these infections is your own immune response. So if they already have a kind of dampened immune response, then it's not going to hurt them as much.
So what's next? Are you going to go up to Canada and pop some poop pills?
No, well, poop pills haven't really shown any indication for anything that I have.
Oh, okay.
That would be like a C. diff. If I got C. diff, yes, I wouldn't go to Canada, though. I'd just find a donor of my friends.
Yeah, I heard there's a guy that's developing an actual poop pill where it's got a triple ply coating, so it only, disintegrates in your either small or large intestine.
Yeah, that's the group Emma Allen Verico's group, I think. Yeah, that's very promising.
Yeah, it looks interesting to me. It's just the fecal transplant reverse, just going in the other end.
I spoke to microbiologists during the course of my book that were doing this back in the 50s, and then they were told to stop doing it. They didn't understand why it worked. They just knew that if you were going to do surgery and give someone antibiotics, you should give them some of their own poop after.
Yeah.
And then whatever the administration of that hospital discovered that they were feeding people their own poop in pills, they were told to stop. But here we are 60 years later, and it's like this miraculous cure. So this is not total news.
Yeah. Yeah, so what are some of the best approaches or lifestyle change that you can give the listeners to increase old friends in the body and their benefits?
What I always say to that question is I'm only willing to recommend things that I know that have no cost and lots of potential benefit. Nothing is proven yet, so the answer is we don't know. But there are things you can do, like eat better, like eat more real food, like lay off the refined food, lay off the junk food, all that stuff selects for unfriendly bacteria. That's not going to hurt you. It's a lot of potential benefit, very low potential cost. Exercise, a lot of potential, the stuff you already know, right? Do all that stuff. The stuff that you can maybe sort of take away from some just thinking differently is when you take your kid to the doctor and the doctor says they have an infection or they have otitis media, what have you, you can say, do we have to use antibiotics? I wouldn't say don't use antibiotics as a rule, as a hard and fast rule, because if you don't, kids die from infections. But you may find that your pediatrician is surprisingly receptive to the idea of waiting and seeing if something clears up because it might be viral. Because they're worried about antibiotic resistance these days. So that's another thing. But again, I don't think you should just swear off antibiotics as a rule for your life.
Yeah, I mean, they save lives. They are effective in many cases.
Yeah. So, and then the other thing is, daycares have been shown to be protective against allergic disease, and the thinking is just because the kids are in there swapping bugs, that is, native bacteria. So don't worry so much about that kind of stuff. Maybe, it's true that kids also in daycares get sick more often because they swap bad bugs as well. But in the end, it might be good for them. So
yeah, but we need that to modulate their immune system to make them mature. So
I wish I had something I wish I could say, go get a tapeworm.
Yeah.
But I'm not willing. We don't know the costs and benefits yet of that stuff. It's actually being worked. It's being studied. That whipworm I mentioned at the beginning, that's being studied in people, and then we'll know some of the potential side effects. We'll know some of the potential, does it do in a small number of people? Do these parasites that aren't native to humans end up in the wrong places, which would be really unfortunate. Like your brain.
Yeah.
So there's that kind of thing that you always have to think of. That's why I'm not always willing to be so willy-nilly about this. Like the hookworm underground. Hookworms at least are native to humans. But again, it's a totally unregulated experiment where a bunch of people who grew up in the first world who never encountered a parasite are suddenly introducing them into their body. No one really knows what could happen because of that. People who have parasite infections typically are people who've grown up with parasite infections, which is a very different proposition than a 40-year-old taking a parasite and putting it in their body. I doubt there's a problem. Parasites are very, in that respect, sort of, they seem to be relatively safe, but you never know. You could trigger something else. They could end up being worse off. You just never know.
Yeah, I've always fantasized about infecting myself with a tapeworm to aid weight loss. But let him eat all the food that I'm eating. But it's just fantasy. But I have a question that I like to ask all of my guests. What do you think is the most pressing health issue in the world today?
Well, I think our most pressing issue is our lack of contextualizing the current suite of diseases in an evolutionary context. That is, instead of always focusing on symptom management and not trying to look at what root causes are. So it's like a vision problem. I guess I use another analogy from, of course, ecological science, which is there's something called shifting baselines in ecology where, let's say, 400 years ago we started whaling very, very crazily in the ocean, killed all the whales essentially, no more whales. You start fishing, you kill all the fish. And what happens, each generation is used to a different baseline of marine life until the first generation, like in Boston, there were actually whales in Boston Bay. The last generation, there's no more cod anywhere in the North Atlantic. There's, that is, the stocks are extremely depleted. That's normal for the current generation. No one backs up and looks at what the ecosystem looks like in its sort of pristine state and what it should get back to. And I think in a lot of ways, that's the problem when we look at disease and with the immune system. No one backs up and says, well, what does the immune system look like in its evolutionary context? What else was there? How did it really work when there's a bunch of parasites? And we know the parasites are over there all the time. How does the immune system work when there's parasites present? It works very differently. I mean, the irony is there's some really interesting studies out of Israel where, they have immigrants from all over the world. Some of their immigrants come from Ethiopia. The immigrants from Ethiopia have all these parasite infections. They come, they try to vaccinate them. The vaccines don't take because they have all these parasite infections and their immune system is so suppressed. And they complain about it. They say, well, we got to deworm them to even get these vaccines to work. But here's the irony. They might be seeing the way the immune system is supposed to work. What they call hypo-responsive, as in not responsive enough, may actually be the sort of way that it's always operated. It's less responsive. It's less easily provoked. Those people are still alive. They still survive. Clearly we can survive with less immune activity than we think. So that's my analogy. I guess my exhortation is that if people would back up and look a little bit at the bigger picture, I think we could probably sort of ask the right questions for the chronic diseases that are afflicting us.
Yeah, that's very compelling. Absolutely. So can you tell the listeners a little bit more about you and where they can find you and whatnot?
Well, I'm a science writer. I'm a journalist. I write for the New York Times fairly regularly. I've written for Mother Jones as well. You can go to my website, Moises, V like Victory, M like Mary.com. My book is available on Amazon, An Epidemic of Absence, if you want to read it. I'll have more stuff coming out in the near future. I'm giving a TEDx talk next month, supposedly, and just go to my website. All that stuff will be there, moisesvm.com.
Oh, yeah, I have to definitely check out that TED Talk. Absolutely.
Yeah, that'll be November 16th. It should be up after that.
And that will be up on their website?
It's a TEDx event, so it's not the main TED website puts up stuff that from TEDx events that they like. They don't always put up everything all the time. It'll be on my website.
Okay, great. Well, Moises, thank you for coming on the show. I'm thrilled that you agreed to come on and help people to understand why they, should be afraid of not having enough healthy bacteria in their body. And, thank you for writing this invaluable book to explain the true underlying cause of many health issues that are plaguing our society today. It was a really good read. I really enjoyed the book.
Well, thank you, and thanks for having me.
Yeah, because I started to read it thinking like, oh, another probiotic gut book. But it was really drew me in how you wove your points into the stories that you told. It was really, really well written. I really liked it.
Thanks so much. Appreciate it.
So everyone, if you want to learn more about health, you can find me on Facebook and Twitter at I Will Live to 110. I'm also on YouTube at Wendy Live to 110. And if you want to learn more about weight loss or the modern paleo diet, my version of paleo, go to live to110.com and sign up for my free 30-plus page Live to 110 by Weighing Less e-guide and my 14-part email series about the modern paleo diet, which are all about how to live a long, healthy, disease-free life. And thank you, listeners, for tuning in. Remember, the time to be thinking about your health is while you still enjoy it, not waiting until you get sick. So thanks so much for listening to the podcast. I'll see you very soon.